This is a short demonstration of the Sol 200 web app. When you first start using the Sol 200 web app, you come to the home page. 5 of the most commonly used web applications are listed here on the home screen. You have the optimization web app for Nastran Sol 200, the multi-model optimization web app, the machine learning or parameter study web app, the HDF5 Explorer, and the viewer web app. Now, if you want access to all the other web apps, you can click this link at the bottom center, and this will give you a full listing of all the other web apps that are available in the Sol 200 web app. In today's demonstration, we are going to be focusing on the optimization web app, which is this left-hand icon. Let's go ahead and click that icon to access the optimization web app. Now, whenever you want to perform an optimization, there are 4 steps to configure the optimization. The first step involves configuring the variables. After this, you configure the objective. Then you configure the constraints. And after that, you assign the constraints to different load cases. For today's demonstration, this is the analysis model we are going to be working on. We have this 3-bar truss that's pinned at the top 3 nodes, and at the bottom 4th node, we are going to apply different forces to this model. And in the analysis, we are going to consider over 10 load cases. The goal is as follows. We want to minimize the mass of this truss, and the way we are going to do this is by varying the cross-section area for each truss member. And by the end of this optimization, you'll find that each cross-section is actually smaller than it was before. One very important part of the optimization process is clearly defining the problem statement. Here, we want to vary the cross-section area of all 3 truss members, so we are going to have 3 variables. We are going to define the objective as minimizing the mass, and we are going to define 2 constraints. One to constrain the axial stress, and the displacement in one of the nodes of the truss. So let's go ahead and look at the starting bulk data file. The assumption is that you've already configured a Nastran bulk data file that's complete with the mesh, the materials, and the loads. You've already configured all your load cases. You've already configured this for Sol 101, 103, 111, or any other solution sequence. This has already been configured prior to this demonstration. So now we come back to the web app and we select that bulk data file. And the first section we are taken to is the variable section. You notice that we can define size, topology, topometry, or topography design variables, but today we are focusing on size variables. If we look at this table identifies all the different properties that can be optimized. Here, I can use the search function to quickly find the cross-section area for the truss members, and I can click these buttons to set these properties as design variables. In the next table are my 3 design variables, and that's it. We are done with variables. We can now move on to the objective section. Here we have a long list of all the responses that can be set as an objective. Specifically, I want to set the weight as an objective. Once I've set the weight as an objective, I can configure the objective as you see here on the screen. Notice that here on the right is the corresponding bulk data entry. Whenever you modify the variables, the objective, or the constraints, the right section is going to have the corresponding bulk data entries. And now look what happens when I modify the bulk data entry. You'll notice that the value, the entry, is immediately updated. Right now, it's configured to use values of 1. Look what happens when I change the values to 3. The corresponding values in the bulk data entry are immediately updated for you. We are now done configuring the objective. Let's move on to the constraint section. I want to define a stress constraint and a displacement constraint. And here in this next table is where I configure the axial stress constraint. And again, notice on the right hand side of the screen, the bulk data entries are immediately updated for you. Here, let's go ahead and configure the displacement constraint. Here we've imposed bounds for the stress and the displacement. Now, let's suppose we made a mistake. If I go to the variable section, let's go ahead and suppose that I made a mistake in the bounds. Let's go to the constraint section, and let's suppose that I forgot to specify a node number here. If I go elsewhere in the web app and then try to download this configuration, I get told that there is an error in this optimization configuration. If you try and run this optimization, it will fail during the optimization. A failure during the optimization is the most common challenge when trying to perform an optimization. But here the web app tells me exactly where the error is. Here, let's click on this link. It takes me to exactly where this first error is. Now, if you have a lot of configurations, here we have a lot of variables, the status indicator is red. This tells me that this variable is the problem variable. Here, I get descriptions of what the errors are. Let's go ahead and fix the error. The status icon is now blue, telling me that this configuration is ready for the optimization. Let's go back to the exporter and now focus on the second error. Here, I'm taken to where the error is. I find the displacement configuration has an issue. Here, let's supply the necessary data. If I go back to the exporter, the error is now gone. So each section in the web app has these status indicators, which makes quickly finding the problem relatively easy. We're done with the constraint section. Let's move on to the subcases section. Now we have a lot of subcases to focus on. Here, let's go ahead and individually assign these constraints to different load cases. If you want something faster, you can use these two buttons here to either deselect or select the constraints for each load case. So here we've unassigned the constraints and assigned the constraints to each load case. Now this is a very big time saver if you have hundreds or thousands of load cases. Now we are done setting up this optimization. Let's go to the exporter and download the new set of bulk data files. Let's go ahead and open the new set of bulk data files, and let's go ahead and start the optimization. Let's look at the new bulk data file and move it side by side. Here on the left is the original bulk data file that was configured for SOL 101 or a statics analysis. Here on the right is the updated bulk data file. It's now configured for SOL 200 or optimization. Each subcase has been updated with the necessary commands for the optimization. Here we get a status page of the optimization, and then after the optimization we get a results page of the optimization. This first plot gives you an idea of the change of the objective during the design cycles. Here we see that we have minimized the mass of the truss. In this next plot, we see the change in the variables during the optimization. Here on the right, I can control which variables are displayed. Right now, we're looking at variable x1. In the legend, I am told that this is the area for prod 11. Let's turn on the plot for variable x2. This is telling me this is the area for prod 12. Alternatively, I can turn on all the checkboxes, and now I'm looking at all the variables. Here, after we're done inspecting the results, and once we're comfortable with the results, we now have to do the following. We have to go to the original bulk data file, which is here on the left. We have to go to the prod entry that controls the cross-section area of the truss members. We now have to update these values manually. So the new optimized value is 0.82, I believe, 0.34, and 0.82. But this is very complicated if you have thousands of design variables. In the optimization directory, there is a workspace B directory and a new bulk data file called model final. This bulk data file here on the right has been automatically updated with the new cross-section areas, which is another time saver. So if you look at the cross-section area fields, they are now 0.82, 0.36, and 0.82. And here on the left are the original values of 1, 2, and 1. So perfect. We didn't have to manually update these values by hand. This was already done for us by the web app. So now, what's there left to do? We now have to visually confirm the change in the cross-section areas. So if we go back to the home page of the web app, we can open the viewer web app here on the right to look at the previous cross-section and the new cross-section. Here on the left is the initial model, the initial bulk data file. Here on the right is the updated bulk data file. If you look carefully at the cross-section areas, you'll notice that the updated model on the right has smaller cross-sections. This is indication that we have minimized the cross-section areas. Another thing left to do, we want to look at maybe the responses. We want to look at the displacements or the axial stresses. We also have an option to look at that data. So let's go ahead and turn off the cross sections and let's go ahead and look at the results. So here right now we are looking at the axial stress. Let's go ahead and rotate this model a little and let's zoom in so we can look at the axial stresses. So here you can see that one of the truss members has an axial stress of 20,000. That is actually the upper bound of one of the constraints. The optimizer has minimized the cross-section area until the axial stress was on the verge of being exceeded. So overall, this has been a successful demonstration, a successful optimization. You'll notice that we didn't have an error during the optimization. We were able to successfully perform the optimization on the first try. And this is one of the biggest benefits in the web app. We can successfully perform the optimization with little trouble. And that's the end of this demonstration.